So for question 2, we have to graph and solve, giving the solutions in set builder notation and in interval notation, and that's relative to these two inequalities, which involve absolute value. So let's deal with A, and we have the absolute value of 2x plus 4, which is less than or equal to 3. Well, our first goal is to dispense with these absolute value bars, and we can do that anytime the inequality is pointing to the left. We can simply rewrite this as a combined inequality, and in so doing we can dispense with the absolute value bars. And if you were to do two cases, you would arrive at this conclusion. And it's so convenient to just simply recognize that you can use the two inequalities and replace 3 with -3, or whatever it happens to be, on the left side of the leftmost inequality. Now our next task is to isolate 2x, so we'll subtract 4 from each interval, and -3 minus 4 is -7, and that's going to be less than or equal to 2x, which is less than or equal to 2, and -4 plus 3 is -1. Now our next task is to isolate x, so we'll divide each interval by 2. So -7 divided by 2 is -7 halves. 2x divided by 2 is x. And -1 divided by 2 is -1 half. Now, we're ready to graph. And there's x, and so we'll put a hash mark at -7 halves, and another one at -1 half. And let's see, we have equal signs associated, so we'll use solid dots. And let's pick a point in this interval, for example, -1. Now -7 halves is less than -1, and -1 is less than -1 half. So if one point in an interval works, then every point in that interval works, and we can shade that region. If we pick a point in this interval, such as -1000, it will not satisfy that inequality, nor will a point in this interval such as 1000 satisfy it. So there's our graph, and by the way, for set builder notation, we simply have to put in our such that vertical line x, and our set notation for interval notation, we're going to have -7 halves, bracket on the left, -1 half, bracket on the right, and we're done. Set builder notation, graph, and interval notation. Now, let's do B. And here we have the absolute value of 3t minus 4, which is greater than 2. So now the inequality is pointing to the right, so we do have to do two cases. And this is a case where 3t minus 4 is less than 0. This is a case where 3t minus 4 is greater than or equal to 0. So for this case, we can dispense with the absolute value bars if we replace 2 with -2 and flip the inequality. In this case, where 3t minus 4 is greater than or equal to 0, we can simply dispense with the absolute value bars. It's greater than 2. Now we'll isolate 3t, so we'll add 4 to each interval. And 4 minus 4 is 0, and 4 minus 2 is 2. Now we'll divide both sides by 3, and we get t is less than 2/3. Now, to isolate 3t here, we'll add 4 to each interval, so we get 3t, and minus 4 plus 4 is 0, and 2 plus 4 is 6. Now we'll divide by 3, and dividing through this side by 3, we just get t, and 6 divided by 3 is 2. So now we're ready to graph. And here we are, have a hash mark at 2/3 and a hash mark at 2. Open circle, open circle. Now let's pick a point in this interval. How about negative 100? And this inequality is solved by that. Or, excuse me, negative 100 satisfies this inequality. So if one point in an interval works, they all work. Notice if we put 1 is in this interval, if we replace t with 1, well, 1 is not greater than 2, nor is 1 less than 2/3, so no point in this interval works. On the other hand, if we replace t with 1,000, 1,000 is greater than 2, so if one point works, they all work. And there's our graph. We've shaded appropriately. In set builder notation, we have the set t such that t is less than 2/3 or t is greater than 2. In interval notation, we have negative infinity to 2/3, parenthesis, parenthesis, union, parenthesis, 2 to infinity. And we're done.